So there are two different types of graph. There's the XT graph, which is position in meters over time. So when you think about the slope, slope is your rise, meters, divided by your run, seconds. Those are the units of speed. So on a position graph, slope is your velocity or speed. If you have a positive slope, you're moving away from your start point. If you have no slope, you are not moving at all. And if it's a constant slope, then that means it's a constant velocity. Now, you can have a negative slope, which means you're getting closer to the object. And since it's a constant speed, a constant slope. Now, notice that on this graph, there are negative position values. That means that if an object is at negative 20 meters, say at 35 seconds, it is 20 meters behind the reference point or the start point. If it's at negative 40 meters, it's 40 meters behind where it started. So this is just telling you about the speed. The slope of this graph tells you about the speed. If you want to know anything about its change in position or the distance that it traveled, um, you would be reading that off of the y-axis. Now, it's a little different when you talk about a velocity graph. So think about the units on a velocity graph. If I want to find the slope, it's the rise meters per second. Sorry. Okay, sorry, I had to cough. Uh, It's the rise over the run. Meters per second divided by seconds again. The units of that is not speed. It is not meters. It is meters per second squared, which is acceleration. So on a velocity graph, your slope is your acceleration. If you have a constant slope, you have a constant acceleration, like in our lab, right? If you have no slope, you have no acceleration. And since this is all on 8 meters per second, it means you're traveling at a constant speed. So you were getting faster here for the first second. And from 1 seconds to 10 seconds, you were traveling at a constant speed. And from 10 seconds to 12 seconds, your speed is decreasing. It does not mean that you're backtracking in direction because your velocity is positive. Remember up here, when you have a positive slope on this graph, that means you're moving forward. So down here, the direction of motion is the sign of the velocity. Is the velocity positive? It means you're moving forward from your start point. If this had negative values plotting down here in the bottom, then you would be moving backwards, but you're not. You're just slowing down from 10 to 12 seconds from 8 meters, from a speed of 8 to a speed of 4. You're decelerating. You have a negative acceleration, and it's a constant negative acceleration. And then you stop speeding up or slowing down, and you stay at 4 meters per second every second. So let's talk about the change in position. Okay. When you find the area under the curve here, you're finding your change in position between over a time interval. So from 10 seconds to 16 seconds, what's happening? So here's a rough sketch of that graph. Okay, you sped up from 0 to 8 meters per second in 1 second. So on a dot diagram, imagine a car is doing this and it's a little toy car and it's got oil or something that's dropping. And if I were to make a dot diagram just to show what was happening to its distance over time, it would be accelerating. So the dots would be getting bigger and then it would travel at a constant speed when the drop and the dots would be for 10 seconds 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, evenly spaced. So here is accelerating for 1 second. And for 10 seconds, it has a constant, I'm just going to abbreviate CV, constant velocity, right? Constant velocity at 8 meters per second. And over the next 10 seconds, now, excuse me, from 10 to 12 seconds, it is decelerating. So now the dots are going to get closer. Actually, let's make this a little, I'm going to get closer, like here. Mm, like that, get closer. So it's decelerating. It's a negative acceleration in this particular instance. And then it is going to travel at a constant speed and it's much slower. Okay, so it's only going 4 meters per second every second. So the dots would be equally spaced here, but they would be actually further apart because it's only 4 meters. Actually, I'm sorry, closer spaced because it's traveling slower than it was over that 10 seconds. So like from 1 to 10 seconds, it was traveling at 8 meters every second. So they're further apart, 8 meters, 8 meters, 8 meters, 8 meters. And from 12 to 16 seconds, it's traveling 4 meters, 4 meters, and 4 meters. So this area here is once again constant velocity. So notice in no time did I ever go backwards, right? So I have no negative displacement here. What you're trying to find is how far it traveled while it was slowing down and then traveling at a constant speed. So you're finding this distance from this point to this point. And to do that, you're going to find the area under the curve because of dimensional analysis. And if you've had calculus, this is an integral. You're integrating this. But if you've not had calculus, it's simply the area under the curve because um, I'm going to find 1/2 of BH for that triangle. And then I'm going to find the area of this big rectangle here, which is BH. And I'm going to use my scale on my X and Y axis to figure out my base and my height. So for this particular example, it's going to be 1/2 of the base, which is 2 seconds, times the height, which is 8 meters per second, because it goes from 0 to 8 meters per second. Actually, that's not true. It's only, we're only doing this little part right here. So it goes from 4 meters per second to 8 meters per second, which is a difference of 4 meters per second, plus that big triangle, which is from 10 to 16. And 10 to 16 is 6 seconds, times the height, which is 0 to 4 meters per second, or 4 meters per second. So you'll get 4 plus 24, or 28 meters. Notice um, that the seconds are canceling out. You're just using dimensional analysis there to get your meters. So your velocity graph, the slope is acceleration because the units are meters per second over seconds, or meters per second squared. And so if you want to know what direction you're traveling in, you're not going to look at the slope here. You're going to look at the sign of your velocity vectors, of your values on velocity. If it's a positive velocity, you're moving in a forward direction. If it's a negative velocity, you're moving in a backward direction. And on a position time graph, it's different. You are going to look at the shape of the position graph. And remember that the slope of a position graph is velocity. So if the slope is positive, and it's constant, the slope of this line here is the speed that you're traveling at. It is the constant speed. So in this case, it would be 60 divided by 10, or 6 meters per second in the positive direction. But over here, it will be this from 15 to 40, which is 25 seconds, right? One, two, yeah, 25 seconds. You went from 60 down to negative 40. So if I were going to do that, it would have to be, mm, I would have to find how far I traveled. I went from 60 to negative 40. So this is my first point would be 60 and 15. And my second point would be negative 40 and 40. And I would find my rise over run using my slope formula, like for math. And I would find that I was traveling at a negative value in meters per second, which means I'm traveling backwards. And that's why just common sense, I'm 60 meters out from where I started. And at 30 seconds, I'm where I started. And at 40 seconds, I'm 40 meters behind where I started. So if I were going to make a dot diagram for this one, I would have dots equally spaced for 10 seconds. And then I would have dots on top of each other for 5 seconds because I'm staying at the same place. Then I would have dots going backwards, equally spaced from 15 to 40 seconds. And then I would have dots going forward, equally spaced from 40 to 55 seconds because the slope of that is positive, right? What I'm doing is at 40 seconds, I'm 40 meters behind where I started. And at 50 seconds, I'm at about 30 something or 27 meters behind where I started. And at 55 seconds, I'm actually where I started. So I'm going back forwards again from the negative 40 line forwards until I get to where I started. I hope that helps.